All
Let me
right,
find
so
the FE handbook real quick.
okay, so today we're gonna go over transmission lines. How familiar with transmission lines are you?
Me?
Yeah,
Not too much.
I'm not either, so it'll probably be a learning experience for both of us.
Yeah.
That's why we
Dude,
have
you're taking
intern.
360 this semester, right?
Nah, I'm taking it next semester.
All right, then.
'Cause, I wasn't able to take it with Ahmed because well, he's taking a sabbatical.
Yeah.
Hey, so this is gonna be problem one of our transmission lines right here. Let's see.
Dude,
Yo, what's up?
do you have the digital copy of the book?
It's a hardcover copy that I'm
Okay,
having right now.
never mind then. Because I figured it would be easier if you just take a picture and post it on Discord or something.
True. Maybe if I do that, then probably I can give everybody time to um know what to expect.
Yeah.
Good idea.
I thought there are two other people responded to that thing. I don't know.
Apparently not, I guess. Oh, oops, the options.
Transmission.
Okay, so we got ourselves a transmission line with a inductance and capacitance of 2.5 microhenries per meter and 1.1 nanofarad per meter respectively. The line is terminated with a purely resistive load. The standing wave ratio at the load is 3.0. Most nearly, what is the load resistance? 25, 50, 100, or 150 ohms. So for the standing wave ratio is represented like so in this equation. Oh, shoot. I've been doing a lot of today Saturday just seems to be the day where I do extra instruction. This and then also what was it? Family friend wanted me to tutor her son in calculus.
What?
Yeah.
For free?
No. I'm getting paid.
Nice.
It's a terrible gamma sign. But yeah, I'm getting paid for that tutoring session. So here we got to solve for gamma. If we're gonna Here we got to solve for
Oh, dude.
the reflection constant. What's up?
Let me see.
Actually, hold on.
I think you guys disabled the sharing files on FE Electrical or something because I can't send anything there.
Oh, my bad. I'll be sure to let I'll let I don't know, Nick know if we really need to share files. Why do I keep erasing the?
Yeah, because I have the exact formula for it, and I make a screenshot, but I couldn't put the screenshot on Discord. So,
Oh, okay. That's
yeah,
weird.
but I see it. I see what you wrote there. Okay. standing wave ratio. Standing wave ratio is
which we all know is 1.0, but we got to solve for gamma, the reflection constant.
yep.
And then, of course, we know how to solve for variables with literal equations. Just got to bring all terms with the variable we're solving for onto one side. All right, so we know that our standing wave ratio is 3.0, so we just got to do 3 minus 1, 1 plus 3. So our reflection constant is 0.5.
Yeah, that's what I got.
Okay, and then for the reflection constant, we got to do gamma is going to equal ZL minus Z naught, and then ZL plus Z naught.
Yep.
We simply need to find ZL, the load resistance. So similar process, just solve for ZL like so. Yo, yeah, do you also watch those gamer troll videos?
What Game of Thrones videos?
like the kind of videos where like someone goes onto like a I don't know, like any game, like multiplayer game, and they start like trolling the entire server.
Yeah, all the time, man. What kind of game though?
Have you heard of this YouTuber named Oni Plays?
I don't think I've heard of him. What kind of games does it play?
He plays like any game, like any Steam or like popular game or whatever. He's actually currently playing the new Avengers game.
Is it out? Damn.
Yeah. So basically, but there's one video that's like my utter favorite where he was like, he goes onto like a Gmod Harry Potter server and he starts like messing with everybody. Like he manages to turn the entire server against the admins by being obnoxious.
Oh my god.
Like what was it? He was telling all the he was playing as like Professor McGonagall, and he's like, "Hey, you with the orange stupid sweater! I challenge you to a duel, you little fool!" I challenge you to a duel because you're a fool covered in drool at school.
No, those people are seriously really creative. I don't know, man.
Oh shoot, that's the wrong symbol. It's supposed to be gamma. This is the first part of study sessions, guys. When you get really distracted, you start to lose focus.
Oh shit. Oh wait, you guys are gonna post it on YouTube, right?
Yeah.
Oh crap.
It's okay though. I don't think anyone's gonna care. You know, gotta get that viewership.
Hey guys, if you guys are listening to this, like and subscribe, you know. Hit that like button.
Okay, so also I almost forgot to I should probably mention this after the recording is done.
Okay.
It involves like remember when you were talking last time about TVP?
TVP? What's that?
Tau beta pi.
Oh, yeah.
Yeah. What was it? I'll mention this after the session is done.
Okay. Cool.
Out of curiosity too, speaking of honor societies, what was it? I was going through the Eta Kappa Nu website because actually I didn't even know about the website until like way later. Are you part of Eta Kappa Nu?
I am.
Oh, okay.
Yeah. But they're not very active right now.
Not
be honest.
reactive? What do you mean?
Active. They're not very active.
Oh, okay. I
Yeah.
think Josh. I think there was this like one E student named Josh Huang who mentioned that they are, how do I describe it?
Looking for officers?
I think he mentioned that they like merged with IEEE.
Did it?
I think so.
I don't think so. Because I'm the secretary and the webmaster for IEEE right now. I mean, Ida Kappa Nu.
Oh, okay. That explains why I haven't gotten any like updates from them. Because like, wasn't Marco one of the officers?
Yeah, he is too.
Yeah. Then it's like, why haven't I heard anything from them?
What did you tell him?
I have no idea. Actually, I haven't even spoken to him lately. I haven't like gotten any updates from Ada Kappa Nu at all. Like, I joined December 2019.
Yeah, I was with you in the induction.
Oh shit.
Yeah, but dude, they're not very active right now. They had at FE workshop merged with Tau Beta Pi, and then that's it, I think.
Mm-hmm.
They were planning to do some FE, no, not FE, what do we call it? Workshops, like 310 and 346, if I'm not wrong. Revision for the finals, but then they cancel it.
Oh, darn it. That sucks. So Ada Kappa Nu is like something that you just add onto your like like your resume or something.
I guess.
Kind of a bummer because like most employers won't like care if you like they won't really care unless like you did something with it.
Yeah, that's true.
But anywho, so if you see the work that's done right here for load resistance, or rather load impedance, I don't know why they use Z for resistance.
I was about to say that.
but it's 150.
Yeah, I got that too.
Oh, okay. All right, that's good.
Let's go on to the next one.
Alrighty. Okie dokie.
Dude, do you know how much time they spend on the FE mechanical workshop?
I think about an hour.
Just an hour? Because
Yeah.
honestly, I don't think an hour is enough for this kind of things.
Yeah, that's true. But you most actually I noticed too that the pattern seems to be like one like hour session with students what was it? My part-time job also like usually has like 1 hour sessions with the students. It's I work as a math instructor for Mathnasium.
Oh, okay.
So yeah, we usually hold like 1 hour sessions. I don't know. I think that's like the normal pattern for these type of things. All right, so number 2, a transmission line has a characteristic impedance of about 75 ohms. The load at the end of the transmission line has a characteristic impedance of 377 ohms. Most clearly, most nearly the percentage of the signal voltage that is transmitted to the load is either 10, 30, 50, or 100%.
Characteristic impedance. Okay.
So if you remember the gamma equation for our reflection constant, it's ZL minus Z naught over ZL plus Z naught. So let's see, load. Okay, load is 377. Well, what's up?
No, I just saw the formula because that's another part to it. So it also equals to V minus over V plus.
Mm-hmm.
So I'm guessing that's the ratio, right?
Yeah. So we need the gamma constant so that way we could figure out the percentage transmitted. So that's about 0.668. So then the percentage transmitted would be transmitted. That's basically 33.2%. So closest we're going to get is B for this problem.
Wait, hold up. So the percentage of the signal voltage, how did you come up with that?
The percentage transmitted?
That is transmitted to the load. I'm a little confused actually. So V, that ratio, how do you explain it?
The gamma ratio for the reflection constant?
Yeah.
It's a ratio involving the difference divided by the sum of your characteristic and load impedances. So
Okay.
once you have your impedances set, you find your gamma constant for the reflection constant, and then from there you're able to figure out how much percentage of the signal voltage can be transmitted.
Okay.
So are we good here on number 2?
Yeah.
Okay.
Did you check the solution?
Yep.
Okay, cool. Yeah, got it.
Alrighty. So next up, number 3. Alrighty, so a lossless transmission line has a characteristic impedance of 100 ohms for a 100 megahertz wave traveling at 70% of the speed of light. most nearly the capacitance and inductance of the line per unit length are 29 picofarads per meter and 0.29 microhenries per meter, 48. I'm gonna lose my breath if I say all the options. If the capacitance and inductance of the line per unit length are as follows. So the characteristic impedance is only shown, so that means we need to consider what our load impedance will be. So that's definitely a missing factor. And now this time we seem to have a wave traveling at 70% of the speed of light with 100 megahertz.
Mm-hmm.
That is an interesting problem indeed. I know the characteristic impedance is going to be Z naught is going to be the ratio of the square root of inductance and capacitance.
Yep.
So we're going to try to find one of the variables. Should we start with L or C?
Okay. I'm not sure.
Okay, let's start with C right here. So that means we're going to need to square both sides. And then rearrange to get C to the rearrange to isolate C, and you get C is going to be L over Z naught squared. And the velocity of propagation, well, we got to include a velocity in here. Hang on 1 second. Oh, okay. Found it. So the velocity is going to be 1 over the square root of LC, which is 70% of the speed of light, which is about...
Wait, where do you find that?
I went on Wikipedia, like right there. It literally says for a lossless transmission line, it's given by velocity factors 1 divided by L over C.
The heck?
And thankfully, this is what the problem is. It's a lossless transmission line.
Oh my god. The
What?
current version of the FE handbook doesn't have that. Or I don't know how to find it, probably.
Oh, okay.
So this transmission line.
We got C right here.
What does that V stand for again?
Velocity.
What velocity?
Wait, what?
What kind of velocity?
This. The wave that is traveling at 70% of the speed of light. So now up to this point, we've got L squared over Z naught characteristic impedance squared is equal to 1 divided by the square of the wave's velocity. So Z naught is 100. So that means we're going to go L squared over 100 squared. That's 10,000. So literally all we need to do to figure out what the inductance is literally square root everything. And 100 squared divided by the wave's velocity squared, it's perfect. It's just 100 divided by 2.1 times 10 to the 8th. That's about 4.76. Wait, is that right? Yeah, roughly, yeah. Wait, hold on. No, Henry's, my bad. Why did I write farads? That's about roughly 0.48 microhenries per meter. So now that we found L, we could safely say that it's basically B at this point. But if just for the sake of it, if we did find capacitance, all we need to do is just plug in L and Z naught, and we're good.
Mm-hmm.
Yeah, it's about 48 picofarads per meter. Yep. So this problem right here is this problem's answer right here would be B.
Wait, do you use the frequency of the wave?
Surprisingly not.
Interesting.
Yeah, I kind of know. Yeah, it's kind of irritating how some problems like they just like throw in an extra detail there that's not even like relevant.
Dude, I can't find that formula that you wrote in the FE handbook.
What you can't find what?
The velocity formula.
Oh, I had to literally Google that just to find the velocity.
Where do you put in Google?
I literally just typed in velocity transmission line, and there should be like a page right on Google that could tell you. It could be Wikipedia.
Oh yeah, I see it. Oof.
Yeah, that's why I had to look it up.
Well, it's not on the FE handbook. I'm gonna make a note to find it later.
Okay.
Because to be honest, this whole thing is more about how to use the handbook. Because there's no way you can remember everything.
Yeah.
Okay, thanks.
Okay. So, let's see. Okay, so a lossless transmission line has a propagation constant of 2.5 radians per meter when transmitting a 50 megahertz signal. Most nearly, what antenna length will be equivalent to 1/4 of a wavelength of the transmitted signal? So our answers are going to be in pi this time. 0.2, 0.5, 0.8, or 2 pi meters.
Okay. So beta is 2 pi over wavelength.
Yeah.
What's the wave? Oh, 0.5. Meter. Wavelength of a transmitted signal.
Oh, oops. Pi, not. Yeah, this one's pretty straightforward. Basically, once you get your wavelength right here, you just need to divide it by 4.
Okay.
Is there a course in Long Beach on transmission lines? Or is that just 350?
I think it's somewhere in 350.
I didn't even learn about transmission lines when we got into 350. I think it's partly because of, the pandemic and everything.
Yeah. Well, I dig my own grave for that course when I decided to take it with Slayman. So.
You changed the grading option?
No, that was a long time ago.
Oh, okay.
For some reason, I got an A for that. I have no idea why.
With Sleeman?
Yeah.
Yeah, I think that's partly why I think a lot of people like Sleeman is because he seems pretty lenient and just gives A's out.
Yeah, but it's not good, dude.
Yeah, I know. That's why any class, regardless of the professor, I always go the extra mile to look up whatever reference materials related just so I can look at it myself.
Mm-hmm.
Okay, so which of these statements concerning transmission lines is false? So this is a conceptual question. A standing wave is the sum of incident and reflective waves. B, the reflective coefficient is the ratio of the reflective wave voltage to the incident wave voltage. C, the magnitude of a standing wave is constant at a given position of the transmission line. Or D, the standing wave ratio is the ratio of the maximum and minimum current magnitudes of a standing wave.
A and B sounds right.
A and B?
Yeah, I'm not sure though. C's right too. Standing wave ratio. D sounds weird.
The standing wave ratio is the ratio of the maximum and minimum current magnitudes of a standing wave. Let me see. Okay, remember with the standing wave ratio, we were, it had to involve the gamma constant. 1 plus gamma divided by 1 minus gamma.
Yeah.
So I'm thinking D sounds right.
Sounds right, really?
Maybe, yeah. This is a maybe, though. Standing wave is the sum of incident and reflective waves. Well, then again, with standing wave ratio, you're able to get the gamma or reflective coefficient, which is the reflective coefficient. So I'm guessing A could also be right.
Okay.
You said A was right, right?
Yeah. I'm thinking the answer is D, but I don't know.
Well, I'm kind of leaning towards C.
Where do you think so?
So apparently, according to the book I'm using, the magnitude of a standing wave is at a given position along the transmission line will vary with time. So C is false.
Okay, cool. Does it explain anything for D?
Not really. It just kind of reiterates for A, B, and D. It just kind of reiterates what the option says. So it doesn't really explain jack.
Oh well, I guess we just accept it.
That was pointless. Once again, another straightforward problem. Okay, so number 6. Oh yeah, also, did you feel the earthquake last night?
Oh yeah, dude. Jesus.
It was a 4.8. That means we were that close for it being a moderate magnitude.
Oof. Dude, I was just lying in my bed and everything started shaking like crazy.
Yeah, in my case, the window was shaking, and then like I kind of noticed my computer monitor was kind of like shaking.
Yeah.
Like I was trying to do like a hula dance or something.
Dude, I was legit freaked out.
I was like, what the hell? And then like I literally had to drag out my trash bag of recyclables just so I could like slip under the table if I needed to.
Nice.
Even then, I could have just probably had my desk. Okay, so a sinusoidal voltage wave with an amplitude of 5 volts propagates in a transmission line. The line has a characteristic impedance of 25 ohms. Oh. And the transmission line is loaded at its end with an impedance of 50 plus J 25 ohms. So ZL is going to be 50 plus J 25. And Z naught is 25.
25.
So if you remember from the gamma coefficient, it's basically just ZL minus Z naught, ZL plus Z naught. And then if I recall what number 5 said, this was it's a voltage wave.
So gamma is going to be 0.4 plus 0.2 J.
We have to take into account the voltage ratio, though. Because this voltage is taken into account now.
Okay.
So that means gamma is going to equal. Oh, scratch that. Never mind. Let me erase that. So V minus is going to equal V plus times
Gamma.
Well, it's going to equal, well, because we're taking these sides of the equation into account, we got to take into account the impedances now.
I think got 2.2.
That's what you got?
Yeah, I think. I'm not sure. What's up, dude?
Just one. I was watching a lot of those gamer trolling videos today. So, what was it? What he did was he was obnoxiously singing the Harry Potter theme tune, and then he gets banned.
Oof.
He gets banned by the admin. He's like, "No, I'm McGonagall, you fool!" He's like, "You fool! You don't know who you're messing with."
Nice.
God. Let's see, plus J3. Okay, so the denominator should be 10. Yeah, I think it's going to be 2.2 given these complex magnitudes. 4 plus J2 is going to equal Then 2 plus j, and then you find the magnitude of that simply. Yep, 2.2. All right.
What does the solution say?
It said C also.
Cool. Okay, move on to the next one.
Yep. So number 7. This is another conceptual one. So I think we have time for 2 more problems. This one and one more mathematical one.
All right.
When is maximum power transferred from a when is maximum power transferred from a generator to the load through a transmission line? So this is another conceptual one. When is maximum power transferred from a generator to the load through a transmission line? When the load impedance is equal to the characteristic impedance, when the reflection coefficient is 1, when the standing wave ratio is 1. I'm guessing D, because what was it? Reflection coefficient is... Wait, but if the load impedance...
B is wrong.
Yeah, it's not ever going to be 1, so so that means if B is wrong, that means D is definitely wrong. And this
Standing wave ratio.
standing wave ratio is never going to be 0. No way. Even if
They are flipped. B and C are flipped.
yeah.
So the coefficient should be 0 and the ratio should be 1. So A is right.
Yeah. So what was it? Number 7. Number 7's answer, he kind of dives into it a little bit more detail. Basically, Basically, it dives into why, like, the logic is flipped.
Yeah. So Z load is equal to Z impedance, right? I mean the characteristic impedance.
Yeah. Plus, if the darn it. If the load and the characteristic impedances were equal, then the reflection constant would have to be 0.
Yeah.
So we can blaze through one more problem today. What are the reflected coefficients for transmission lines that have terminating loads of an open circuit and a short circuit? Darn it. Gonna have to write the answer out.
What the hell?
Yeah, I know. It's kind of weird.
Terminating loads of an open circuit and short circuit. I have no idea what that means.
What a open circuit or a short circuit?
Terminating loads of an open circuit and a load circuit.
Terminating load. Okay, so electrical termination is essentially the practice of ending a transmission line with a device that matches the characteristic impedance. So it's got to involve the load and, well, I mean, given that it's gamma, it's of course it's going to involve the load and characteristic impedances.
Dude, the first one is at 0 times gamma short circuit.
Yeah.
And that equals to 1.
Where you're talking about A?
Yeah.
Let's see, short circuit. Well, if I remember anything of a short circuit, it's that if I remember anything from short circuiting in the circuits class, basically a short circuit is where you there's no resistance.
No impedance. Okay.
And then with a open circuit, that's where it's where the
impedance is infinity.
Yeah. So in that case, that means if so if we set this to infinity right here, actually, if you set both to infinity on the top, it's just going to be infinity over infinity. So you might as well use L'Hopital's, which is just 1 over 1. So 1.
Okay.
So that's for OC. And then SC. That's when sounds like
the load is
the load has to be
0.
0. Yeah. So that means negative ZO over ZO. That means negative 1. So 1, negative 1.
Oh, that was a comma, dude. I thought it was 0 times gamma short circuit. I'm so confused.
Oops, maybe I should have made it a semicolon there. Okay, well, apparently that was also conceptual and math-esque problem.
That's not too hard.
Alrighty. We have 4 more problems left on this. So I'd say we could probably finish it up next time, and then we can move right on to the next chapter after this is power distribution and overcurrent protection.
Okay, cool.
So 4 and 4 from each chapter.
You wanna do one last one and then we'll just move on to the next one next time?
Okay. So that means we could do number. I got one.
Transmission line term?
Yeah.
I'm guessing there's no unit.
No, it's got to be. It can't be unitless
Why not?
because you have to take into consideration the impedances.
Okay.
So it's definitely. I don't think it's D. It's A, B, or C. So ohm meter. Wait, but if it's 1/ohm meter, that'd be conductivity. But except you need resistivity to like transmit a voltage.
Hmm.
So it's definitely not A. I'm starting to think we should have played the music for Who Wants to Be a Millionaire when you're like have two options left. um okay, ohm meters.
Wait, where do you get the related formula for this?
Huh?
Where can you get the related formula for this? Like,
Let me see. Transmission line unit.
dude, also, I highly recommend that you don't rely too much on Google. Because while taking a test, the only thing you can have reference to is the FE handbook.
True.
Yeah, so you're gonna learn how to use it.
Okay. Do you have it in the handbook?
Huh? Yeah. Okay. Let
Okay.
me send you a link. So this is the one I'm using. Right there. And there's also a link for the handbook in our Discord. So yeah, it's under it's under FE Mechanical.
Oh, okay.
Yeah. I think that's the updated version too.
Oh, wait.
Yeah.
There was a fundamental equation in a previous problem that we did that could have tied to this. Okay, so in a transmission line, in number 3, it was characterized that the impedance would be the square root ratio of inductance and capacitance.
Okay.
So, and that's characteristic impedance. So that means it's a resistivity unit. And also, apparently, if you overthink, you're going to waste a lot more time and
Yeah.
lose more points. Alrighty. So we got about like 3 more problems left in this unit, and then afterwards we could get to power distribution.
Okay. We should just probably move on.
Okay.
Dude, was that the exact wording in the question?
Yeah.
Transmission term?
Yeah. I'm copying it word for word, so that way nobody gets confused.
That is so weird. I guess that's the terminology for it.
Or it's also because it's like, well, weird wording.
Probably.
Alrighty.
Alrighty.
So,
Thanks, dude.
all right. So next time we will finish this up, and then we'll go on to chapter 28, power distribution.
Alright.
Alrighty. I'll see you later, Hien.
See you. Thanks, dude.
No problem. See you next week.
See ya.